The next step is to take the batteries I have processed that have made it through the QA process and start building them into a battery pack. So here I will show you the process that I'm going to use. These are pouch cells, and they're generally flat and rectangular. They're difficult to work with because the connections are random. You never know how they're going to connect. In many cases I have to extend the bus bar. I'm going to use PVC card to separate each battery. Now this is not ideal because in high heat conditions this would break down. But this battery is not going to be run hard, and I'm not too concerned about heat. I'm going to be using it very, very carefully. Low current charge, low current discharge, so this battery will have an easy time. It's never going to be abused, and I'm not worried about it. Next, I will take high temp tape, looks like this, and I will only use high temp tape inside this battery. It's also called Kapton, and this will not distort or melt too bad when it gets hot. This is really tough stuff. It's actually quite affordable. It's highly recommended when working with lithium-ion batteries and building battery packs to always use Kapton tape. It's not that expensive. Some of these cells, the bus bars, are a little bit odd, and they're not in the right place for the pack that I'm building. I'm going to extend the bus bars whenever I need to using standard nickel strip. This bus bar on the battery, this is the positive end, is not in the right location. So when that happens, I have to extend the bus bar using nickel strip to go with the connectivity scheme that I've planned for this battery. So it's a lot of extra work, but I have to do it. I do not have a spot welder. I wish I did. So I'm just going to use solder and Kapton tape to hold everything in place. I'm going to trim up this bus bar. Right about there. Now I'm going to take the bus bar extension, and I think I'll bend it right about there, make a 90 degrees out of it. That'll give me a little tab to solder to at the top of the battery. At the top of the battery is where I'm going to be making the connections, so I don't want to have wires going up underneath or anything like that. Everything's going to be done on the top where I can see it. I'm going to take the Kapton tape, use that to anchor the bus bar in place. Hopefully it won't move. Actually, I'm going to need to trim that. So this is very tedious work. I'm not especially going to worry about how it looks. These batteries will be closed up inside a container, and I'm not going to sit there looking at them. Next task is I have to solder that bus bar onto the other bus bar. I have to solder the extension on. And trim the solder blob off carefully. Doesn't need to be perfect. Okay, so the bus bar is extended. I'm going to be protecting the bottom of these batteries very well. Next, I will continue wrapping the battery with Kapton tape. I don't want to have any part of the battery exposed because these are cans, and they're aluminum cans, best I can tell. And they tend to conduct all over, and it's really, I don't want any chance of short circuits. The Kapton tape is plentiful, and I'm going to use it to protect the batteries from short circuits and to keep everything held in place. I have a lot of it, I might as well make use of it. I'm going to make sure and protect the bottom of the battery as well. Now these batteries will be further protected once they're installed inside the case. Okay, so this would be the positive, this would be the negative. These batteries are a bit odd. It seems like this would be the positive, but actually it's not. Next thing I'm going to do is I'm going to straighten the bus bars. The way I'm installing these batteries in the case, they're going to have vertical bus bars. I really don't look forward to doing this, but I'm going to take the pliers and make it 90 degrees, make sure I don't short anything out. Next thing I'm going to do is I'm going to put the battery in my little clamp here, and I'm going to verify the polarity and voltage of this battery. So I should have positive on here. This is the bus bar I added. And you see I have 3.8 volts. Positive is obviously this bus bar on the left here. And what I will do is I will mark that. So I'm going to try to put a mark right on the top. Next step is to put some solder on these bus bar terminals here. Next part of the procedure is to attach a 5 amp fuse. Every single battery will have its own fuse in case anything goes wrong. I don't think it will, but I'm not going to take chances. So the entire battery pack, each cell will have its own fuse. Actually, each cell will have 2 fuses. Because the way these fuses are, it's cheaper and easier just to go ahead and use a fuse on both terminals. It looks kind of ridiculous, but it works for me. It's serving my purpose. And so that's how I'm going to do it. There's the fuses attached to the battery cell. In order to save time, because this is an extremely laborious process, extremely lengthy, I normally don't do things like this. I've never recycled cells before, but I need a way to save time. And so what I'm going to do is I'm going to use Kapton tape, and I'm going to wrap each fuse with Kapton tape to insulate and protect the terminal from short circuits. This doesn't look the best, but it does the job. And I don't want to cover up the actual fuse because I want to be able to see that. And I have plenty of this tape, so I'm going to keep using it. I have several rolls. I must say it doesn't stick all that great at first, but it seems to eventually stick. When you're first putting it on, it doesn't seem to have a lot of stickiness on it, but it stays on there and it stays put. So, and I know it isn't going to melt. I know it's plenty of insulation for what I'm doing, and it'll do the job. So now I have a battery with 2 5 amp fuses, 5 amp rating. Okay, and there's the completed battery. This is very tedious, and I have many cells that are going to be going into this battery bank, so yeah. Before I use this battery in the battery bank, I'm going to go ahead and check it one more time. 3.8 volts, positive on the left, as marked. Everything's good, so this battery's now ready to go into the next step of the process. Next step is I will strap this battery to a PVC plastic card to anchor it in place on the sides and also on the bottom. Each battery will have a card separating it from the neighbor. I'll try to get them lined up. It's not going to be perfect. And the battery will just sit right on there like that. Line it up. Wrap the tape around. Make sure that the tape is reasonably tight and not loose. Make sure the battery is seated. Next, I'll take another card and I'll make a sandwich. You can see how that's going to look. And I'm going to try to keep these lined up. They need to be lined up pretty well to fit in the case the way I want them to. Then I'll take more tape. And this is rather fiddly. Go ahead and put the tape on the car, that should help. The entire time I have to make sure that I don't short out the terminals. Of course those fuses would blow, but I don't want to have to go and repair those. Now I will probably have some additional insulating material in here, but this is just to get the battery bank built. And that creates the first cell. Let me go ahead and add one more so you can see what that looks like. Okay, there's what the stack looks like. I just keep repeating this process over and over again, and it takes a while, but you really have to do your homework. These cells are quite volatile, and nothing should be shorting out. Hopefully, once this is all done, I'll be satisfied with the results. So far, so good. At the end of each battery box, there's going to be a gap, and here is where the battery terminals will be connected. There will also be a fuse to protect the entire group of cells. There will also be room to add additional cells if, for example, one of these 3 batteries has a lower amp-hour capacity than I expect. There will be enough room to get 1 or 2 more cells, or however many I need, in here and balance out these 3, because I want all 3 of these to have about the same amp-hour capacity. They don't have to be perfect, but they should be relatively close. Inside the battery box, I can use this foam material, which I have plenty of. This will give the batteries some additional protection on the bottom and on the sides. The next task is going to be to attach the bus bars. This will be the negative, this will be the positive, and the bus bars are going to run down this way towards the battery terminals. These nickel strips came with the battery box, and I will use them to make the bus bars. There's what it looks like installed in the battery case. You can see I have barely enough room to get my bus bars on there, but I'm only going to need a few connections down at the end for the fuse and the battery terminals, and I can add more cells here until I'm about right here. It's possible I may leave the foam out because there isn't a lot of room in this battery case, and on the sides I'll probably have to find some much thinner foam. Each battery will be fused internally using a standard 20 amp automotive car fuse and 2 connectors. Each will be heat shrinked to make sure there's no short across this fuse. There's the fuse that will protect the entire battery. The main power wires are soldered on temporarily to the main terminals of the battery box. Once everything is finalized, these will need to be heat shrinked and if possible double heat shrinked to ensure that these wires never fall off of the terminals. Even though there is a fuse, that is a very unsafe condition. If either one of these wires were to come loose, that could be a serious problem. There is also Kapton tape insulating the bus bars, but now it's time to test the battery. There's a look at the work in progress. It appears on the outside like any other UPS battery, so I'll need to make sure and mark this as a 3.7 volt lithium-ion battery. Otherwise it could be mistaken as some other type of battery. 3.81 volts, very good. So this battery is ready to be tested and used. I like the clean appearance of these battery boxes. I think they're a little bit overpriced for what they are. But when you have a lot of cells that are mismatched and they're fragile and recycled in all different shapes and sizes, this is a good alternative to just leaving them out in the open, unprotected. This battery box will give these batteries some protection, and if I put enough foam and enough packing inside, they should be just fine. Let's go ahead and see if we can put a charge into this battery. I've got my bench power supply turned on to 4 volts. I've already checked the polarity, so I know that's correct. Let's go ahead and plug this in, and it's taking a charge. This battery should be able to handle a lot more than 65 milliamps, I would think. Could just do a half an amp for now. So the battery's taking a charge, it works. It looks good. The battery cells are well protected inside. I would call that a success. But unfortunately, I have a lot of work left to do, as I would need a minimum of 3 of these batteries in series to produce any kind of meaningful voltage. I want to have at least about 10 to 12 volts of power, so once the other cells are available to me, I can use them to construct the rest of this battery bank and end up with 3 fairly large batteries, and could be used for all sorts of different purposes, including running a small inverter, charging cell phones, running lighting, and so forth. Well, I'm not going to show the rest of the details, as it would just be incredibly repetitive and boring. When building a recycled battery, it's very important to have secure connections, to use high temperature tape, to use foam or padding or something all around the batteries to protect them from shock and impact. In addition to that, it's important to segment each battery cell individually from the neighbor, because usually recycled cells are odd shapes and they may have an unexpected form factor or something you weren't aware of, and you do not want any chance of those batteries contacting each other. For example, you never want to take 2 cells like this, random cells, and just stick them together like that and wrap some tape around them. Extremely dangerous because you don't know exactly how these cells are constructed. Many of them have odd shapes and odd ways of connecting. That's why I use a plastic card to make sure there's no possible way the batteries can come into electrical contact with one another. In addition to that, the judicious use of heat shrink is highly recommended. Everything should be heat shrinked, including the fuses, all connections, bus bars, and so forth. As you can see, this is incredibly tedious and a lot of work, so recycling lithium-ion cells is very time-consuming. Hopefully the cells that I recycled will be useful for many years to come. Make sure if you ever do a project like this, always think about how the system could fail. Try to imagine if something came loose, what would happen? How do you protect against that? And also, you'll notice here I did not put the batteries in series inside the case. That was to simplify the connections. So these battery boxes would be connected in series outside, and that allowed me to do all the monitoring of the balance and so forth outside the case. Inside the case, it's simply an all parallel connection. There are no series connections, there are no computer chips or anything else. There's just some fuses, and that's it. That way, what's inside this case is as simple as possible, and all of the monitoring and balancing and so forth can take place outside these cases, where you can see everything and make changes if you need to. Thanks for watching, and I'll see you later.